All right, let's talk about the derivative of 1 over the square root of x. This is a particularly difficult derivative to calculate with a limit definition because of the fact that it's a fraction or a rational expression with our variable in the denominator, and we have the square root. So we're going to have to take care of both of those issues in 2 different steps. So first of all, let's just plug our function in and start dealing with it here. So f of x plus h would just be 1 over the square root of x plus h. And then f of x, we already know, is 1 over the square root of x, all over h. All right, now the fun begins. What we're first going to do is take care of the complex fractions. We do this by just multiplying the numerator and the denominator of this bigger fraction by the LCD of the numerators. Or the numerator fractions, excuse me. And by the way, this LCD is always, not always, but you can always just multiply by the actual denominators, which I'm doing here. And then let's see what the result of this will be. This should take care of those fractions up there in the numerator. When I distribute this to this first one, the square root of x plus h's cancel. And what I'm getting left with is just the square root of x. And then when I do that distribution, or I distribute that to the second term, the square root of x's cancel, and I'm just left with the square root of x plus h. And then down here in the denominator, nothing happens too nice. I just multiply all of this stuff together, and there's nothing really to do at that point. Okay, so as said before, that first step just took care of the fact that I had fractions up there in the numerator. What I still have are these square roots. So the way that I'm going to take care of these square roots is I am going to multiply this by the conjugate of the numerator here. So what I'm going to do is multiply by the square root of x plus the square root of x plus h. And I'm going to do that the same here in the top and the bottom. When I do that, in the numerator is the reason why I'm doing all that jazz, is because this is the difference of squares or multiplication of conjugates. When I multiply these together, what I get is the first term squared. So the square root of x squared is just x, and then minus the second term squared, and then the square root of x plus h squared is just x plus h. Making sure I have these parentheses here. That's really important, just to make sure I'm going to distribute that negative here in 1 second. But let's get our new denominator here. I'm just going to put that there. So it's that times what we multiplied by, which is the square root of x plus the square root of x plus h. Okay, so what do we do now? Let's distribute this negative through up here in this numerator. And when I do that, I'll get x minus h. And then what I'll do is cancel these x's. That just becomes 0. And what I'm going to do in this move, because I'm sick of rewriting that denominator, is I'm going to cancel this factor of h right here with the factor of h right here. In fact, then what that means in the numerator, I'm left with a -1. So let me rewrite all of this. Okay, and again, that last move I just did right there where I canceled that factor of h is a huge deal. That was the main goal of all of this. Now my denominator will not go to 0 when I plug in a h, and in fact, that's what I'm going to do now, or plug in a h equals 0. So if I plug in h equals 0, which I can do because the denominator doesn't go to 0, that term right there then goes to 0, and this term right here goes to 0. What I will have after doing that then will be the limit. Oh no, sorry, I took the limit, excuse me, sorry about that. What I have now is no limit because I evaluated by plugging in 0. I have the square root of x times the square root of x plus 0, which is the square root of x, times the square root of x times the square root, or plus, sorry, the square root of x down here, because again, the x plus 0 right there is just the square root of x. Cleaning this up just a little bit more to get a nice final clean version of this will give me, I get -1, and then I get this x times x right here, or square root of x times the square root of x, which actually ends up just being x. Then over here, the square root of x plus the square root of x is 2 square root of x. That is the main work of the problem. So we did all that, and I'll review in 1 second. But what I want to just say is we can clean up this denominator a little bit more by combining these x factors. And just to show that work on the side here, that's x to the 1 times x to the 1/2, which would give us x to the 3/2. So I'm going to do that. So I'm going to rewrite this as -1 over 2 times x to the 3/2 for our final answer, our final version of this derivative. Before we finish here, let's just review what the heck we did in all of this mess right here. Again, because we had this rational and the square root, we had to do two separate moves. We did all the way at the top. But the first move here was to multiply by the common denominator to clear those fractions. And then we did this trick of multiplying by the conjugate. What that does is takes care of the square root, specifically in the numerator. Why that helps us is because of what happened in this move. When we were able to cancel that factor of h between the numerator and the denominator, that's a big deal, because then we can do what we really want to do right here, which is plug in 0 for h, because our denominator does not go to 0 anymore. And then these last steps were just some algebra to clean things up to get our final derivative here of 1 over the square root of x is -1 over 2 times x to the 3/2.